All right. Good afternoon, everybody. Good evening to those farther away. This is our second meeting for the Winter Speaker Series. And what we have lined up today is just a quick kind of overview of the working group from me. I know we have a few new people who've joined this year and people who joined late last year. So I'll do that relatively quickly, and then we'll hear from Karlee Prince, who's at University at Buffalo. So what I would like to do is share my screen, first of all, and see if I can get to where I actually want to be. Going to share this one, and then I will, before we get to the good stuff, I'll bring up some slides. So as I look at my other screen, I can see that I am in fact sharing. So I think that at least for the folks that are present with the live Zoom here, I've had a chance to meet everyone at one time or another, but I'll introduce myself anyway. My name is Ben Laabs. I'm one of the organizers of the working group, along with Leif Anderson, Philip Lee, and Joe Licciardi, who's here. We've been doing this now as a working group for, I think, just over 2 years, about 2.5 years. With a few ideas in mind, really just to form a community of folks who are interested in past glaciation, mostly quaternary glaciation in the Western U.S., but also not really trying to hone in completely on the past, but also thinking about glaciation, at least in historic time, and a little bit about modern glaciers too. So for our talks, for our members and followers of the group, we are going to be hearing about the modern cryosphere and thinking about the past cryosphere. But most of what we've pulled together as resources for the working group has to do with mapping past glaciations in Western North America, mostly in the conterminous Western U.S., but I'll show you what I mean by that specifically in just a moment. So really, I just wanted to talk about some updates. If you know people who are interested in joining or following the working group, there are some really easy ways to do that, basically by contacting me in one form or another. I do have an update to the working group website that includes the Winter Speaker Series schedule, so you can look ahead over the next few weeks about what's coming up and where to find recordings of anything that you might not be able to attend live. We do have a couple of cryosphere sessions that will be at the Rocky Mountain GSA in Provo this May. That meeting is from the 18th to the 20th and has at least one field trip that has to do with past glaciation. And then I'll talk to you a little bit about the Paleoglaciers inventory. We have some updates, mostly ones that are just in the works that we don't have available live yet, but I'll show you what exactly I mean by that. So some of the easy stuff first, if you're interested or if you know someone who's interested in joining the working group, this is an informal group. It's really a pretty simple thing to join. So I have a couple of email addresses that I use. I think mostly for this group, I've used my ndsu.edu. The one that I'll be transitioning to most likely over the summer is my usbr.gov. Either one of those is perfectly fine. We also have a Google form, which allows people to express their interest a little more formally if they prefer to do that. That's linked to the working group website, which you can see here is really easy to find. It's just called paleoglaciers.org. So we do welcome anyone who's engaged in the community, and you don't have to identify yourself as a glacial geologist or a mapper or anything in particular, but people who are studying some aspect of the Quaternary period, present glaciation, past glaciation, I think they're the ones who will gain the most out of the community. We don't really have it open to non-scientists, I think, at this point, but it really is easy for people to find what we're doing through the website and to listen to our talks through the recordings on YouTube. So if you go to the website, this is I let AI build my talk, so some parts of it are going to look a little bit funny, but you can kind of see what the homepage layout here is. At paleoglaciers.org, you can see our very brief statement about who we are and what we do here. Really just trying to get a better understanding of Quaternary paleoglaciers based on the best information that we have available. And I think it's really nice to have a group like this, since when we go to conferences, we're all sort of spread out. It's harder to gather at those things. It's nice to have these sort of sub communities, or what we've identified ourselves as a working group. And for what we've done so far, we've been able to gather and share information with just a minimal effort, a meeting just for a few weeks a year in the wintertime, kind of in between the conference season, and giving an opportunity for people to share what they're working on and share information too. So check out the website. There is some stuff there. It's something that can expand quite a bit, and I expect it will as we get a little bit farther along here. Let's see. Make sure people can see what I'm pointing at as we go through the next few slides here. So we will do for the speaker series over the next few weeks, we will have a pretty consistent meeting times through March 6th. We are likely going to postpone Anthony's talk from March 6th to a later date. Hopefully it's one that is still available to most of us to participate in, but Anthony's told me that he's working on just getting a little bit more data for this presentation. And then for the 14th, when we hear from Augusto Lima, he'll be presenting from Norway, so it's possible that we'll do an earlier meeting time just like we did last week. But generally speaking, we'll do the 4 p.m. Eastern, 1 p.m. Pacific. We'll alternate Thursdays and Fridays. That's why we have some shorter times between meetings, longer times between others. And that just makes it easier, I think, for people who can either meet on Thursday or Friday, but not both. So that's the main reason for doing this. And if you take a look at these titles, you'll see that we really do have quite a bit to look forward to for the upcoming presentations. So one of the products that we've been trying to put together for the working group, and this has actually benefited quite a bit from input from the working group so far, is this Paleoglaciers inventory for the Western United States. So what we've done so far is we haven't really tried to merge too many different existing inventories, but just with the conterminous Western U.S., we put together a set of paleoglacier outlines as geo-referenced polygons. And this is how you can find inventories for other parts of the world. For example, the Alaska Paleoglacier Atlas. This is one that's been around for a long time. It's been revamped by Joe Tulenko and others at Buffalo. So we're really putting together something that's similar to that, but at least at this point, not really trying to merge too many of these things. Bethan Davies, who we heard from last week, has put together the Pat Ice reconstruction, or the Patagonia ice sheet reconstruction. And again, we're formatting this in a very similar way to make it accessible. So the current version of this, which I'll show you how to get to in just a moment, this was updated mostly in the early part of last year, at least in the the one that you can download now from these different access points that I've included here on the slide. But there are a bunch of other updates in progress. It just takes a little while to compile information to get everything properly attributed, and then also make decisions on how we want to represent it. For example, one of the things we did last year was we added some of the Southern Laurentide ice sheet margins, Southern Cordilleran ice sheet margins to the database. And we just have to decide how those are actually going to fit in as a single layer or separate layers or so on. So these things are coming down the pipeline here. And what I'll do for the moment is just take a quick break from PowerPoint, and I'll show you different ways that you can look at the database. So you don't have to be, even though the database is shown here, you still see that hopefully. You don't have to be a ArcGIS user in order to access it. We do have it represented in different formats so that you can use it in whatever GIS of whatever your GIS of choice is. So I'll show you some details about that in just a moment back on the website. But here's what it looks like. So actually, this is not what it looks like. Here's what it looks like if you download it and bring it into your GIS, whether it's ArcGIS or QGIS or Google Earth. This is the type of this is basically the extent of the inventory as you would see it. But since we've been working on adding to this compilation, and there are some things you might notice right away, like this big chunk of Idaho right here. Looks like it's missing some data, and that's because it is the way that many of these data were originally organized was for the Quaternary glaciations volume from back in 2011. And so as people were contributing to that, there were some kind of funny boundaries that that fell into there. One of them that has a interesting four corners right here at the Yellowstone ice cap. I see Joe smiling at that. So it just happens to be where that corner showed up. And there are a few others that just pop in here as artifacts. But as we've been working on expanding this, it turns out that there's more to Idaho, and we've been able to find that. It's still incomplete here, but just a line outlining the one of the quaternary margins here, sort of roughly drawn, some others that are drawn in a little bit more detail. And then some outlines that show where the ice sheets and mountain glaciers were starting to interact a little bit more. So these just need to be cleaned up a little bit, represented in a way that we think they'll be most useful to people. And then we have a couple of others that have just didn't show up initially when we did this compilation along the southern Cascades here, some areas in California. So what's shown in the kind of lavender lilac color, I guess you could say, is what still needs to be added and what we're working on adding, and the same with these line drawings right here. So there's always more to add. We want to be able to keep this thing updated and released as frequently as we can, but it does take a fair amount of effort in GIS to be able to do this. As I mentioned before, you don't have to look at it in ArcGIS. If you don't want to, you can look at it in Google Earth. And so we do have a KML version of this. It's a little bit trickier, I think, to use it, but if you wanted to get the attribute information in KML, you could certainly get it. You just have to kind of deal with all these individual polygons over here. Just find it a little bit more challenging to organize things in Google Earth, but if you know ways to do that, then you probably won't have too much of a problem with it. But it is pretty easy to move this thing from an ArcGIS or a QGIS layer into Google Earth. So I'm happy to share this KML with you if you'd like, but you can also generate it on your own, just depending on what kind of GIS you use. And then if you are a ArcGIS or ArcGIS Online user, it is possible to go in and just do a search for Western U.S. paleoglaciers in that ArcGIS Online search field here, and you'll pull up a handful of things. You'll probably pull up these top three, not so much the bottom one. I think that's private within my Bureau of Reclamation. ArcGIS Online, but everything that has NDSU attached to it here, that's publicly available. So if you wanted to download the outlines as a shapefile, if you wanted to connect to it as a web feature service, which is really easy to do in QGIS, or if you wanted to connect to it as a feature layer, that's the way to go. So if you download the shapefile, you can use it, but then it becomes static at that point. If you connect to it as a web feature service or a hosted feature layer here, and we were actively updating the inventory, you'd be able to see those updates in your GIS as it's going. It doesn't update that frequently, so you're probably pretty safe with the static version for now. But that is what we have available. So I just wanted to make sure that that everybody knows that. And what I just wanted to try and gain from people while we have folks online here is just a little bit more information. Just curious how many folks have, actually I'm gonna, so I can see you all. Just curious how many folks have accessed the database before. Maybe just do a show of hands or thumbs up or something like that. Okay. Should have put together something clever like a Zoom poll. Oh, well, I can only ask AI to do so much, right? All right, so a handful of folks have done that. Maybe I can just, this will work better if people turn on their microphones. I can change my view here. Tell you what, I'll just stop sharing for this part so I can see everybody. All right, so let's do that again with raised hands. How many folks have used the database before, accessed it before? Okay. All right. And then how about preferences? ArcGIS, QGIS, Google Earth? Anybody want to chime in with that?
I guess so far just Google Earth, but
Google Earth?
Yeah, I think like ArcGIS is like easier to access, but if you are talking about open access data, it's important to make it available in your open access software as well.
Right, right, yeah. Okay. Well, I think we do have some larger questions to try to get to about representing confidence in the reconstruction, having some sort of quality control that goes into this, and I think this may be a discussion for a larger subset of the working group here. But I just wanted to highlight that these are questions that we're, I just go back to sharing my screen here. These are questions that we're working on. You know, if we look at all the different sources which are represented as attributes within the inventory, they really do vary quite a bit in terms of how the outlines were drawn. Were they based on mapping? Were they based on just looking at some imagery that maybe predated LiDAR, or maybe it was based on a mostly LiDAR interpretation, or maybe it was based on some really intense field work and mapping. So there are big differences because these glacier outlines have been drawn just with different ideas in mind, different intentions in mind. Sometimes based on mapping that's already been done, sometimes just trying to get at past glacier equilibrium line altitudes or something like that, where the geometry needed to be close, but maybe not perfect. So it is worth it for us to go through, even though we have about 2,600 polygons or something like that total, just within the conterminous west here. It is worth it to go through and think about scale, how these things should be represented. And the more data, the more outlines, I should say, we accumulate, the more work there is to be done with this. So I think that's an important consideration for all of us, and then how we could actually, enlist the effort of the group, ideally the collective effort of the group, to be able to represent these things and then have some quality control assessment too. So these remain goals that we want to try to work toward within the community. It's always better when these things are backed by funding, to be able to compensate people for their time, and especially if there's going to be some review involved. That being said, if there's anything if you look at the database, anything that's missing, please, and you think can be easily contributed, please do let me know. This is something that remains a work in progress, as I mentioned, and one that I hope we can continue to grow and perhaps one day merge with other inventories from around the world. Okay, so any questions at this point about the working group, about the inventory, anything like that? Comments?
I had a quick question about submitting outlines that have been
Sure.
like new ones that have been generated. Should we email those to you, and what format, or how would you prefer to get them, and any constraints on what kind of attributes should be included, or just kind of whatever we have?
Yeah. I guess we don't really have a formal way of doing that right now, Aaliyah, but you could just download the inventory and try to match attributes that way. As far as IDs and geometry and things like that go, you don't have to have those things, because we can generate those when they get added. But you can just take a look. I think just making sure that credit is part of the attribution, then we can probably take the rest from there. So as far as the format goes, it really can be just about anything. If you're working in QGIS, you can represent them as a layer. If you're working in ArcGIS, you can represent them as a shapefile or a geodatabase or something like that. As long as we can get access to it, we can merge it and update attributes accordingly.
And yeah, would you like those, like if we have some, should I email you like a zip folder with all of the stuff? Is that the best way? Okay.
Yep. Yeah, I think email is probably just the easiest for now.
Okay, sounds good. Thanks.
Yeah, thank you.
Hi, Ben, can you hear me?
Yep, we can hear you, Greg.
Yeah, I was curious. We have our website here at the UGS. We get a good amount of traffic on our hazards web portal and our geologic mapping sites. Is it okay to put a link to the database on our state website?
Absolutely.
Okay, yeah. I'll look into that, and I'll have our web people look into that as well. I just thought that may be one way to get people interested in Utah geology, but it'll send you there, and then maybe get some more input or something.
Sure. I think for that, I would recommend connecting to the web feature service,
Okay.
or if it's all through arcgis.com or ArcGIS Online, you can connect to the hosted feature layer. But everything's attributed properly, so everything that's available now, and I'm sure you know a lot of that covers Utah pretty well.
Yeah, for sure.
So
Okay. I'll have them look into it and let
yeah,
you know. So thank you.
yeah, that'd be great, of course. Okay. All right. Well, I hope that that information was useful. And like I said, feel free to share. If there's anybody that doesn't necessarily want to follow the working group, but they want to just kind of check out the recordings, people are welcome to do that. These are all public on YouTube. So I'm going to stop sharing my screen now, and I think I've got it set up, Karlee, where you can share yours.
All right, how's that look?
That looks awesome. All right, so I need to make sure I can get to your bio here. So we're really glad that that Karlee is here today. She's been doing some work on glaciation in Western New York and getting at a really interesting problem about moraine stabilization. So we're excited for her talk. Karlee is a PhD candidate. She's working with Jason Briner at the University of Buffalo. She received her bachelor's at Northland College, working with David Ullman, who we've seen in the group here before. She worked with him on cosmogenic nuclide exposure histories from 2 sites on the south shore of Lake Superior, and then worked with Dr. Jessica Rodesil at the USGS, investigating Holocene hydroclimate in Floridian lakes. Usually a little bit outside the geographic realm that we're talking about here, but that's great. She has since worked with Dr. Briner, and she received her master's at Buffalo while studying the last deglaciation in Western New York, which we're going to hear about today. And now she's working on reconstructing relative sea level around the coast of Greenland. Take it away, Karlee.
Great. Thanks, Ben. And thanks for having me here today. I'm excited to jump back into this work. We'll see how many times I say Western New York versus Western US. That was fun earlier today, being like, where are we? But yeah, so I'll talk about this deglaciation work that we did in Western New York. I want to first take time to dedicate this work to Glenn Vincent. He was the first landowner in Western New York that invited us onto his land and allowed us to take some cores from a bog. He was a really awesome steward of his land and was really welcoming. So I'd like to give a shout out to Glenn at the beginning of this talk, who passed away a couple of years ago. And then thank the Geological Society of America for funding. And this whole list of people down at the bottom, because we spent like 2 years straight coring bogs, like almost every other weekend to get a lot of this data. Takes a village. So thanks to everybody there. I'll also start with a land acknowledgement that both the University at Buffalo and the study sites are on the territory of the Seneca Nation, which is a member of the Haudenosaunee Six Nations Confederacy, which is also covered by the One Dish or the Dish and One Spoon Treaty and the Peace of Friendship. And so we thank the Haudenosaunee people for the opportunity to live, work, and share ideas in these territories. So I'll be talking about ice sheets today, specifically the Laurentide ice sheet. I know the map earlier was showing that. I think you guys think a lot about these alpine glaciers in the western US, but my work has primarily focused on the ice sheets that have covered North America since the last glacial maximum. So today we'll talk about Western New York, but I've also done some work over on the Cordilleran ice sheet, and most of my work now is focused on the Greenland ice sheet, if people have questions about glaciations there either. So my work has mainly focused on making ice sheet chronologies, so asking questions about where ice sheets were and when, and using geochronologic tools to ask about when. And I'm preaching to the choir here, but that's important, especially in the eastern US, to track meltwater rerouting events since the last glacial maximum. So trying to figure out things like when the Younger Dryas happened and where that water could have gone is part of why we need to have these nice chronologies of where the ice sheet was and when, so we can understand our climate system. It's also important because there are a lot of new global climate models that need accurate ice sheet time steps, like the height of the ice sheet through time, so that they can model the atmosphere and the climate around it. So this example is from Osmond et al. In 2022, doing a reconstruction of the climate for the last 20,000 years, and they needed like an ice sheet chronology from the globe for this work. And finally, knowing when and how ice sheets react to climate can tell us about how sensitive they are to climate change. So this graph on the right is from Bryan et al. In 2020, where they modeled the southwestern section of the Greenland ice sheet, and they compared that work with a lot of Aaliyah's work, actually, which are ground truthing where the ice sheet was through time with glacial geology, and then modeling it to have confidence in that model that is doing well in the past, so that they can trust its predictions of sea level rise into the future. So that's kind of why this work is important. And the work this kind of work has been done quite a bit in around the Laurentide. And this figure here is from Dalton et al. 2020, their compilation of the Laurentide ice sheet. So starting around like 15,000 years ago in this top left, working to 12.1. And this map is just showing these dots, these data points, the crosses and the circles are minimum limiting radiocarbon constraints showing when ice had to be gone from a certain area for this radiocarbon age to tell us that ice was gone. And I think their work was mainly trying to just draw these lines to the northwest of where we're getting radiocarbon dates saying the ice was gone. And so this is showing us the general recession to the northwest, basically starting around in these panels, they show us beginning at 15,000 and going to 12. But that is a similar time frame that I'll talk about today. So we'll see this kind of northern to northwestern retreat through the talk, and that there is quite a bit of data out here showing showing the timing of this ice chronology. So we studied Western New York for 2 reasons, 3 reasons really. It was we were in Buffalo and it was a pandemic, so it's kind of nice. There's this whole backyard to explore that was local, and also because it was kind of like there's a couple questions here that we want to address. The first of which being our first motivation is looking at the initial deglaciation. So we sort of live in this kind of spatial data gap in Western New York here. Turn on this cursor quick. Good. So this is our spatial data gap here near the Salamanca reentry here, which is one of the northernmost points of the terminal moraine. And there's been a lot of work done to the west in Ohio, where this deglaciation occurs right around like 19 to 20,000 years ago. That's a lot of minimum limiting radiocarbon ages pooled together to get a mean. That work was done by Glover in 2011. And then if we follow this terminal moraine over to like the New York City, New Jersey area, there's been a lot of beryllium-10 dating that show the ice sheet kind of fluctuating at its maximum margin between 26,000 and 20,000 years ago. And then really starting to truck north through the like the Hudson River Valley by like 18,000. And so one of our questions was, is the same thing happening around here? When is the timing of that retreat? And so that's our first question. Our first motivation was just trying to get some constraints on the terminal moraine. And then our second question has to do with the retreat history. So starting around 17,000 years ago, we have some constraints in the region about what the ice sheet was doing. The first major recessional moraine locally is the Lake Escarpment moraine, which if anyone's familiar with the glacial history around here, that turns into the Valley Heads moraine in eastern New York, and then the Ashtabula moraine down into Ohio. And this lake configuration in Lake Erie dammed this lake, and it formed Glacial Lake Maumee, which has some OSL ages on shorelines constraining it to around 17,000 years ago. And then all the way to the east, the Varve chronology, the New England Varve chronology, pins this ice position also around 17. And then there are some younger ages through here reported on this moraine, 2 from some bogs by Kozlowski in 2018 that come back to around 15,000, and then another bog in Western New York that has a, it's not a basal age, but there is a couple of ages that are around 15,000, and their work was to make a projection to the basal age that came back about 17. So that was a data point for this lake escarpment moraine for a long time as well. And then the ice sheet retreated north and created the Marilla moraine. And locally we have an age on that, which comes back kind of in the same era of around 15,000 years on some wood that's over top a glacial Lake Whittlesey shoreline. So telling us that glacial Lake Whittlesey was older than 15,000. And then finally, around 13,000, the ice sheet was far enough north to allow glacial Lake Iroquois to dam Lake Ontario, or to be within the Lake Ontario basin. And there's some good work showing the switching of glacial Lake Iroquois out to like the Champlain Sea around 13 to 12.7. Work done by Cronin and Rayburn up in like the New England area. And then that's kind of that was like the working retreat history. These shape files here, I think we've modified this like Kent Moraine one, but the rest of them are these Dalton et al. 2020 shape files. So these are work that was agreed upon by this whole list of authors to be the retreat history based on the radiocarbon data in the region. And so it was a little bit of a surprise to read the paper that came out right at the beginning of this project, which was Young et al. 2020. And that one had suggested that there was a re-advance of the Laurentide ice sheet that reached almost all the way to the Kent moraine, the LGM moraine, between the time of 13 and 13.3. So when this paper came out and we were already thinking about coring lakes down on the Kent moraine, we were like, oh, well, if this is the case, this is a pretty big revision to the ice sheet history in this region and should probably be duplicated, like to understand if this is something that happened. The data that re-advance comes from are some of these trenches that this group dug, where they would find this kind of clay-rich till that had logs and wood embedded in it. And often they would describe in the paper that this wood had like pebbles kind of like ingrained in it, and the wood would often be stripped off, which was evidence for them to say that this kind of like the wood being so like pressed into this sediment was evidence that it was an ice sheet that had overrun a Alarod aged forest and kind of incorporated all of these wood and these trees into this this till unit. And the ages from this all come back between this like 13 and 13.3 time frame, or the majority of them do. There are some that lie outside of it. And so that's where the timing comes from, which they lined up with the Greenland interstadial 1B, or Greenland something 1B, around 13,000. So this is our second motivation, was trying to go back to some of these places that would have been within the extent of this Alarod re-advance and see if there is evidence for it with some sediment cores. So that's what we're going to be checking in on today, is when did the ice sheet first retreat, and then do we find evidence of this re-advance? So the first thing we were doing was checking out some LiDAR and getting some nice mapping done of where the extent of the moraines were. It was beautiful. If you have a chance and are looking to I don't know, waste some time, I highly recommend going onto CalTopo and playing around Western New York. It has some really fantastic glacial geology. So this is the terminal moraine with these moraine crests kind of like lapping onto these bedrock outcrops that weren't glaciated in these really kettled moraines, really hummocky topography. And so we mapped out this one being the Lake Escarpment moraine, which was tracked over to the valley heads, and then we track it for continuousness and its relative position north of moraines that we know of, like the Kent moraine, but having this like surface expression of like very, very kettly, and usually at the head of these valleys, which is the namesake for the eastern portion of the moraine. And that resulted in a map that looked like this. So this was some LiDAR that we put together for the region, this being Buffalo and Lake Erie. And we have other resources to track the LGM moraine through Pennsylvania. And then we have our little segment here. And that same goes for the Lake Escarpment moraine up here in this lighter red. So our study sites on these moraines this is the terminal moraine, the Kent moraine, and this red line denotes the maximum extent of it. And so we'll be looking at 3 bogs that occur on this segment. One up here, the Allenberg bog, this one the Vincent bog, and this one the Songster bog. Big shout out to both the Vincent and the Songster families for allowing us to be on their land and collect some sediment cores. And then this quarry site I'll talk about, where we collected some sediments for some OSL dating. And then up on the Lake Escarpment moraine, where we'll ask our second questions about the re-advance, have a Dragonfly bog and Little Protection bog. Big shout out to this quaternary dating techniques and paleoclimate class that helped us collect this core. And then back to Erica Duty, Erica Yang now, who helped with the Dragonfly bog. Zooming in, these are the field sites. These colored circles denote what kind of coring equipment we used. Sometimes we just used the Russian P corer. Sometimes we would take a Livingston. And then we also employed this thing called the geoprobe to get at the really stiff sediment at the bottom to ensure that we had like the whole sequence of sediment. So that's what I just said. We have Livingston and Russian peat coring when we can push as far down as we can with our hands, usually getting through the peat and the yicha. And then we were able to use this geoprobe. Oh, it's not showing. But this is a 40-pound slide hammer that works on a half meter collection barrel that you can pound in through really stiff sediments, and then we have a jack to get it back up. And it allows us to take sediment cores that look like this. And this was really useful because then we knew we had gone through all of the post-glacial sediment and down into the till. So we would collect like in one spot we collected like 2 or 3 meters, 4 meters of this. Which took a whole lot of work. They're all like steel and it's very heavy. It's a very heavy equipment. So all of these cores came back with us. We split and pictured them in-house, where we were able to find single macrofossils that were heavy enough to date. We would date just one. So an example here is like this like piece of bark. But oftentimes we were digging out quite a few small bits of sediment or of organic matter that we would collect and settle at once. So we call these ones combined macrofossils. And we send them to NOSAMs and Keck. And then we did 1 centimeter magnetic susceptibility and loss on ignition. And that allowed us to create some of these like strat logs for all the sites. So here we have an example core from Vincent 1 showing some of the geoprobe. This was the top of the geoprobe. I think we had another like couple meters beneath this. And so we have diamicton going into some of these alternating mineral layers, mostly like clay and silt, with very fine, small amounts of organic matter, and then transitioning pretty sharply into like a yicha that then went into a peat eventually. And so this is today a peat bog, and we would core down and find these lacustrine sediments showing us that it was a lake from some portion of its top in the early Holocene. And so we have, MS showing us these high values in the silt, and then higher organic values and water values in these more organic layers. All the carbonate content and all of these cores stayed below 5%, so we don't show those in the paper. And then for our OSL dating, we visited this quarry here. So this figure denotes the delta shape in this blue. This is what the ice sheet extent would have been in this red line, and sediment would have been brought in through rivers into this dammed lake where this Kame delta was formed. So like an ice contact delta. And so we were hoping to get at when the ice sheet was forming this delta, or when it had just finished forming this delta, to get at a constraint on deglaciation. So that's Caleb Walcott collecting some OSL samples and this like nice silt and this nice sand layer on the upper levels of this delta. Cool. So that's how we're going to answer some of these questions. So we can start with our first one. When did the Laurentide ice sheet retreat from the terminal moraine? We'll first start with our OSL because we were just there. And we have 2 samples right next to each other. And they both came back right around 20,000 years. And this was surprising for us because we were like kind of expecting this to be a very messy system, having sediments coming from beneath the ice sheet into a Kame delta can basically not allow the sediments to have a lot of time exposed to light to reset these traps. But we used a minimum age model and the data looked pretty good. So we're excited about these 2 ages, while also acknowledging that they are only 2 ages and they came from a pretty dirty system. And then we can get on to the radiocarbon dating from all of these cores. So this is the 5 sediment cores that we have from the terminal moraine, the 3 from Vincent, 1 from Songster, and Allenberg. And wherever we see these stars are where we have radiocarbon ages that I'll flash next. And so generally, some of these cores started at the top of the sediment column, some started like right before the mineralogic layers started. So the top is sometimes present and sometimes not. And what we find generally, the first place that I want to bring your eyes is the base of the sediment cores. So this is typically where we would look to find our minimum limiting age constraints. And they're only around 15 to 14,000 years ago. And that's younger than what we expected, since we had estimated this moraine to be about 20,000 years old, or to have been deposited 20,000 years ago based on correlations to the east and to the west. So that was kind of our first wave of results that we got back, and we were like, what's going on there? And then we dug in a little bit more to these 2 cores to find that in this interval here, we had what we think may be rip-up clasts. So this kind of like gray clay that is distinctly different from the yicha that it is in, and also having this kind of classed, like, formed consolidated appearance. Looks like it got reworked into this part of the core. And then additionally, down a little bit farther, we have an organic rich piece that gets kind of worked into this less organic rich sediment. And this has some tricky radiocarbon dating. So the first time we submitted samples, we had submitted some combined macrofossils, so some of these pieces here, and got an HVAC that was 20,000 years old. And that was surprising, but that one also was like, oh, that's kind of, around the time we thought this might be deglaciating. So we went back to get another sample here, and we collected both more material from the same rip-up class, this time in the archive half, and then also some mixed macrofossils from the surrounding sediment. And these both came back younger, around 14.7 to 14.4. So this was confusing, to say the least, and something I'll noodle on next. And the other thing that we found in Vincent 4 was, while they're not necessarily age reversals, because everything overlaps in uncertainty, but it is showing that there was like 2 meters of really rapid sedimentation that fluctuated back and forth between this like really sticky wet clay and diamictons with some quite large pebbles involved. So this was going back and forth, even like organic layers getting incorporated here, you can see, before eventually stabilizing and being just like a organic rich yicha. And so using these 2 cores and thinking through what this data meant, we thought this is our working hypothesis for how this would have happened, which would be that this moraine would in fact be deposited about 20,000 years ago, maybe supported by our oldest radiocarbon age and our 2 OSL ages. And it leaves behind a really ice-rich moraine. So like maybe an ice-cored moraine, and it was like 90% ice with a little bit of till on top. And that's supported by the incredibly kettled moraine that exists in the landscape today. And that for like 5,000 years, maybe it was in a pretty stable position. Whether or not we have permafrost, we don't know, or if it was just enough sediment over top to like really like stabilize this ice, and that the climate was that cold that this ice wasn't really melting. But it was enough to allow organic matter to grow in the summertime and kind of accumulate on the landscape during this 5,000 year interval. And eventually it gets warm enough around this 15,000 years ago, which is right around the Bowling Alley rod, for this landscape to become quite unstable as the ice begins to melt. And we actually get the beginning of the kettle formation, which would then be our minimum constraint on ice sheet retreat. And so that's why the basal ages, or at least the lowest ages in all of these cores, are coming back around 15,000, because that's when the kettles were actually forming, but not tracking ice retreat. And then eventually, after around 13.9, 14,000, we get conformal radiocarbon ages going to present, and that we have some a stabilized ice-free moraine. And so that's so some conclusions here is that potentially ice was retreating from the Kent moraine around 20,000 years ago, based on our OSL ages and our one macrofossil age. And this is pretty well in line with deglaciation ages from the east and to the west, suggesting that we had a synchronous retreat along the southern margin. But that the kettles on the Kent moraine weren't formed until 15 to 14,000 years ago, and that this 5,000 year lag was because of this delayed melting of the ice, of this like ice cored moraine that it was left behind. Okay, so that's the answers to question 1. And now we can think about question 2. And this was if there was a readvance or not. So if this is kind of this like 2 scenario thing, either one, we deposited till on top of, we deposited a new till, it was a new moraine that was left behind by this readvance, and that the basal age from these kettles will be around 13, or we have deposited glacial sediments into these pre-existing kettles. And so we can first check out the yellow stars from our 2 cores from the Lake Escarpment moraine, which are north of the maximum extent of this hypothesized readvance, and look at the basal ages, which are around 13.8 and 15.2. So these are both older than 13,000, and so we don't think that this advance created a new moraine, nor does the stratigraphy and like the moraine's shape really suggest that. And so then we can look at the sediment that occurs through the interval of a hypothesized readvance and see if there's any evidence maybe of glacial sediment through here. But we don't really find that either. It's mostly organic rich yicha through both of these cores. And so we don't think it was that either, but that doesn't really explain all of this wood that they found in this kind of like glacial material. So instead we're wondering if during this time frame between 14 and 13,000, it was similar. It basically was a similar process that happened on the Kent moraine. So our basal ages here are like the exact same age as the Kent moraine, also occurring on a moraine that we thought was around 17,000 years ago. So that kind of brings us back to this hypothesis that 2 moraines that were supposed to be deposited, 2,000 years apart, are also getting the same basal age, and that regionally, this whole region experienced the same lag, and that both moraines melted out around 15,000. So putting that all together, we have the GISP2 core just as a proxy for how warm the northern hemisphere was during the last deglaciation. We have our warm bowling Alarod here, and what we anticipated being the Kent moraine deposition and the Lake Escarpment moraine deposition, and instead finding a lot of our kettle formation ages around the bowling, and maybe having this moraine being deposited 20,000 years ago, but this lag being from the difference between when the moraine stabilized. And then if we plot all of the ages reported in Young et al., they agree pretty well with when we're seeing these kettles forming. So we're kind of putting it in this slot of like landscape instability. Maybe there were landslides or permafrost lumps, things that were causing wood that was growing at the time to be reworked into what we think might be primary, what would look like primary glacial deposits, but are actually just remobilized glacial deposits from the LGM. Yeah, so that's our story. Some other things that we took away was that basal radiocarbon dating in these environments can be quite tricky and extreme, and that we should be cautious when using kettle basins, and that it would be a good idea to target depositional environments that require the ice to be there, things like ice-walled lake plains and proglacial lakes. And finally, to know that you got down to the very basal sediment and that you know that you're dating the base of it and not stopping short somewhere. So that is what I've got, and I look forward to any questions. Thank you.
So I think I might be the moderator at this point because Ben slipped out the back door. Although I still saw he still has a window open here. But anyways, thank you, Karlee, for a really, really great talk. Really interesting. I certainly have questions, but really, really nice work. But maybe we just open it up to the audience here. We are at 4:59 p.m., so I recognize that not everybody can stay here, but if anyone wants to hang on the line here and ask Karlee questions, I think that that she'd be happy to answer them. Or I can start with a question of my own. So the ages that you get, it's really interesting. I guess one question is this, I guess maybe like 5,000 year period where you're envisioning a pretty cold frozen landscape, no kettles being formed. These would have been ice cored moraines at that point, right? Would there have been other processes that might have led to, I guess my question is, would there have been any kettles forming at that time, whether or not they had any water in them or not, just from collapse features occurring? Or do you envision it being like really pretty stable throughout those 5,000 years?
Yeah, I wonder if we were to core, so I'll bring this figure up maybe. Sometimes there can be just a little bit of till between like, the surface and the ice, and sometimes there can be a lot more. I wonder if there were parts of the moraine that didn't have as much till veneered on them, or it was like clear ice or something, and if that the surface expression of the moraine would look a lot different. It would be like thinner probably and not have as much relief. And if we could find even like smaller, shallower depressions, maybe that would have melted out first, because it wouldn't have had like any kind of like debris cover, and it would have been, exposed to sunlight right away. There is some variability in the timing of the moraine of these like kettle formations. Like some are like as old as 15.3, and some are as young as like 13.9. So that's even, like 1,500 change years difference between seeing these kettles form. And something I haven't done but was thinking about after watching an AGU talk was something as easy as like a basin width, basin depth kind of analysis, and seeing if that correlated with how old or young the kettles are. Something like a really deep and small kettle having like the youngest deglaciation age or something.
Mm-hmm.
And that I think would tell us about the sediment cover and how fast they were opening up. So could be more work to be done. We kind of targeted these like nice looking fresh kettles because we were like, oh look, they're everywhere, but hadn't really had the results back to know exactly which ones to target. But we do now have Rebecca Topness working with Dr. Elizabeth Thomas here at UB on some lakes that we think were proglacial during ice retreat. And so we're hoping we can get back into those proglacial lake sediments and find something to date. And those lakes would have had to exist based on an ice dam versus being reliant on the climate to melt them out.
Right. Yeah.
If there was if there's anything to date, if it was,
if you can
it's
find
hard
anything,
to imagine this like landscape. There might have been quite a bit of active layer growth, just not being
right. Okay. Yeah. Thank you. That's a lot to think about. But yeah, I mean, I think it's reasonable to think it's just relatively stable for those 5,000 years.
It's also, thinking one last thought on that, it being like the Salamanca reentry, the ice sheet is up here at 7,000, up here at 5,000, 15,000, excuse me, 17, 15,000, 13,000. It's like compared to Ohio, which had like 500 kilometers of ice sheet retreat between 20,000 and 13,000 versus like, it's an hour and a half drive and it was retreating for a couple thousand years. So I would imagine it was also just like very proximal to the ice sheet and very cold for that reason.
Yeah. And kind of related to that, I also kind of wonder about the, topographic control on that supposed re-advance that that Young and all proposed, right? I mean, there's a lot of question marks in that margin, but why would it have only, yeah, it seems unusual that it would only have re-advanced in that one relatively restricted location.
Mm-hmm. Yeah, I think the paper proposes an ice margin that is able to kind of surge while being like hydrostatically kept above. Like I think a lot of it was there would have been some kind of like proglacial lake sitting on top of very like watery sediments after there having been 2 proglacial lakes in the region, and that if the ice had like surged across it, it would have minimal impact on the landscape, and also like be able to kind of like flow really fast and quickly for a short amount of time, potentially upslope, I think is how they argued it. Yeah.
Interesting ideas there. Yeah.
Mm-hmm. It's hard to explain the wood.
Yeah, that is a little perplexing. Maybe if anyone has any other questions here, one more question, and then we can probably ask Karlee lots of questions offline later if you'd like, and she'd be happy to answer them. It is 5:05.
Sorry for the long talk.
No, it's great. Anyone have any other questions before we close down shop for the afternoon? All right, well then.
Quick one. Oh,
yeah.
Sorry.
Aaliyah, sorry.
Yeah. No problem. Great talk, Karlee. Really cool to see this stuff. I read your paper, which was really great too, but it's good to get some more like field pics and everything like that. I'm curious. So the kettles that you were coring, were those all just on the moraines themselves? Or did you have any like in between the moraine positions? And if so, did you get any like different results? Or is these processes you're proposing, do you think they're just on the moraines or kind of like all across the landscape?
Right on. For your first question, they're pretty squarely on the moraines. So these onto the terminal moraine, they're like, yeah, within this kind of zone of hummocks that we envisioned as being, this like massive ice core moraine. And the same goes for here. So these are both within the swath of the hummocky topography. And so we don't have anything in between, but that'd be cool to get something. However, I anticipate we would get the exact same age from the base. I think we'd get the exact same age from the base of a lot of them, because they don't seem to be spatially dependent on anything. As for what is going on in between the moraines, it's kind of a fun question. If there would have been like ice left over or not. So like ice left over on the landscape that would have been stable for a long time or not. So there are there's like outwash plains that come off of these, the Lake Escarpment moraine that is like pitted outwash. So we could try to, check into some of those kettles or something, maybe if those being isolated, melted faster or something.
Yeah, or maybe if it's, something to do with like permafrost versus, this kind of like ice core sediment, like, what's the word I'm looking for? Insulation to keep the ice core around. Yeah, cool. Thanks. Cool stuff.
Something we looked for a lot. I did a remote sensing class, and one of my project was trying to find those like crop circles that get left behind on some farm fields that are like left over from it's when you have permafrost, the ice wedges separate out the land, and then when they're melting, sand gets in them, and then you have a difference in permeability where you have like a sand clast versus like a farm field that has like till and soil. And so during drought conditions, crops that are planted in the sand class like dry out and they die, and then the ones that have more of like the regular matrix, they last. And so during drought, you can see these like the shapes of all the outlines of the ice polygons. And it's this really good work that Gao did in Ontario and over in New Jersey. And I've looked all over Western New York and I haven't found any yet. I was really hoping that could be like a really cool way to like, like this is permafrost, or like, but no such luck. No such luck yet.
Cool.
Thanks for the questions.
Thank you for the talk. So I think we'll kind of close things down for this week. And just as a reminder, Ben will be sending out, I'm sure, emails about our next round of talks. And hopefully everybody can attend those. And again, they're being recorded. So if you miss one, like I did last week, you can watch them later. So thanks again, Karlee. And good luck with all your current work that you're doing right now as well.
Thanks.
And yeah, we hope to see everybody again next week. So take care.
Good to see you guys.